Okay. Hello everyone. I'm Zhengyu from Red Bull University, and this work is actually from the organizing team. And unfortunately got a cold several days ago, so maybe my voice is not in very good condition. So, but I will try to do it. Okay. I will start with a brief overview of the related work on full seeing classifiers with image transformations. So the first and also the most popular one is that is doing this by adding pixel perturbations, and basically the perturbations are gradually updated using the gradient information from that model, and this process will stop until once the label of the image has been changed. As we can see here, that with the help of the gradient information, this kind of approach can achieve very high fooling effects, but actually because the introduced introduced noisy patterns, it will definitely degrade the image quality. So there are also some other approaches try to use more uniform transformations to achieve the fooling effects. For example, from the previous work, there's something done by geometric transformation, and also from last year of this task, people try the image enhancement and the style transfer. So actually, sometimes we can got even higher appealing of the image, like the image enhancement. So, but the fact is that this kind of approach actually do not use the gradient information of that model. That's why they have poor performance on fooling the network. So the question comes that how can we achieve the strong fooling effects and at the same time maintain the image quality? Okay, from the previous work, we found that some work on using the domain knowledge may help for this purpose. So for example here, that the adversarial gravity and also the glasses is especially suitable for the context of the specific applications. So this gravity and the glasses are created based on the gradient information and at the same time look realistic in that context. So inspired by this work, we propose adversarial photo frame that is specially suitable for the social images posted online. So we try to mimic the real frame that's shared that's used in the social platforms. So what can we do that? So basically we adopt the perturbation approach pipeline and just restrict the perturbations to the border of the images. So the technical part is the same as the perturbation approach. And this figure shows the results from our approach. And on the top row, we can see that our approach did not change much of the image and well maintain the most content of the image. And also on the bottom line, that we add an extra single channel constraint. That means that we make sure that in each RGB channels, all the components are changed by the same amount. So it results in a single color frame. So for the evaluation, we submit five runs with different width of the frames, and also this series is from the just like the top row, and these two are from the bottom row. So from this table, we can see that our approach can effectively drop the accuracy from 100 to 0. Yeah, it's obviously because we use the white box, the gradient information. But if we add the extra constraints, it will be harder to achieve the very good performance. And in terms of the aesthetic score, and we can see that the score of the modified images are close to the original ones, because that we maintain the high proportion of the image content. And also, in all the cases, actually the numbers is higher than the original one. It means that adding domain-specific photo frame will improve the image appeal. And another point is, we assume that modifying more pixels will give lower image quality. But actually, from this table, we can see as we increase the width of frame, we get higher score. So it may because that NEMA evaluation model, it's not will correspond with the human judgment, as everyone knows. And okay, to conclude, we propose adversarial photo frame to achieve the footing effects to protect the privacy, and specifically we use the fully flexible condition of this approach, and also introduce one single color constraint. So in the future work, we can also consider other constraints on the frame. For example, we can make the perturbations in the frame assemble a certain patterns of concept, such as the flowers or the stars, to make it more visually acceptable. Or we can also explore other image retouching functions, as shown in the following figures, that the mosaic stickers. And okay, so in this case, we can play with the settings of these stickers. For example, the positions, the shapes, or the numbers, the appearance, whatever. So to fool the network. Okay, that's all. So, any questions?